on? Oh, now it's on. Now it's on. Kelly, do you want to say hi to YouTube Nation? Okay, all right. We'll just pretend like they don't exist today. We'll pretend like the world centers around us. Did anybody go home and watch the video again so you could hear me rap? You didn't. People said that they were actually going to go home and do that. I feel bad. You didn't say that, though. That's because you went home and rapped yourself, Alex Hagan. Okay. All right, so we've got multiplication and division of complex numbers. And this is not going to be very difficult. I'll list it as this. We'll say Z1. Whoop. So given Z1 is equal to R1 times sine of theta sub 1 plus I, cosines first, my bad, cosine of theta sub 1 plus I sine of theta sub 1, and Z sub 2 is equal to R sub 2 times cosine of theta sub 2 plus I sine of theta sub 2. So that's the trigonometric form of a complex number, right? So yesterday the whole point of yesterday was we wanted to find a modulus, we wanted to graph them, and then we wanted to take something like 1 plus 2i, and we wanted to transform that into the appropriate trigonometric form, which we can use. Well, remember, we could we could take 1 plus 2i and we could multiply that by -1 minus 3i, right? We could do that. You just FOIL it out, right? Well, you can also multiply and divide, complex numbers that are in trigonometric form. And it's actually really easy to do compared to this. Because here you FOIL and then you got to worry about the negatives and all that stuff. Here it's really easy. Watch. If you want to take Z1 times Z2, all you have to do is take the two R values and multiply them together. So you get R1 times R2. You just take the two radius values, multiply them. And after you multiply them, you take cosine of theta sub 1 plus theta sub 2 plus I sine of theta sub 1 plus theta sub 2. So you multiply the R values, you add the theta values, and that's all you do. So what if we wanted to take Z1 divided by Z2? How do you think that would be different? What do you think we would do with the R values? We would divide them. We'd have R1 divided by R2, R sub 1 divided by R sub 2, times the cosine of, what do you think we do with the theta values? We subtract them. Theta sub 1 minus theta sub 2 plus I sine of theta sub 1 minus theta sub 2. That formula is on page 584 in your textbook, so if you need to look it up or reference it, if you can't understand the handwriting or something, it's all listed right there. The formula is extremely simple to use. Watch. We have two complex numbers, Z1 and Z2. What I want to do is I want to find Z1 times Z2, and I want to find Z1 divided by Z sub 2. So if I want to find Z sub 1 times Z sub 2, what do I have to do with the R values? Right, so I just have 2 times 5 times the cosine of, what do I do with the theta values? Add them. So I'd have pi over 4 plus pi over 3 plus I sine of pi over 4 plus pi over 3. Now we just, figure out what that is. What's 2 times 5? 10. What's pi over 4 plus pi over 3? 7 pi over 12. That's it. It's pretty easy, huh? No, that's it. Now, Kelly, you raise a good question, though. This is trigonometric form. We could figure out the cosine of 7 pi over 12 and then multiply it by 10, and then figure out the sine of 7 pi over 12 multiplied by 10, and that would give us, standard form of a complex number. But this is trigonometric form, so we're going to leave it like that. So see how quick that was? That's easier than like foiling and stuff, right? So, and we just tried a basic problem. So imagine more difficult problems, how quickly you could just, make hay of it, right? For example, we just multiplied 2 numbers together, right? Well, you could do 3, 4, 5, you do 20. Trying to FOIL 20 binomials, that takes a long time. But trying to multiply 20 of these really wouldn't be that bad at all. And so it lends itself to some pretty useful things in mathematics. Let's do z1 divided by z2. So what's going to be out front? 2/5 times the cosine of, very good, negative pi over 12. Plus I sine of negative pi over 12. Now, let's see what you remember. We can't have negative theta values. Do you remember your even odd identities from your sheet? Do you remember this? Cosine of negative theta is equal to cosine of theta. So we could just drop the negative, and you have sine of negative theta is equal to negative sine of theta. So that's an even odd identity. That's from your graphic organizer sheet that I gave to you. You've got it right here, right? And the even odd identity is going to be right here. You guys see it? There you go. So we're just going to make that slight change here real quick. So we go 2/5 times, we can just leave the cosine of pi over 12. We can leave that alone. And we'll go minus I sine of pi over 12. And that way we don't have a negative theta value, which we don't like to have. That's it. That's trigonometric form. What do you think about that? Awesome. Okay, so that was pretty straightforward and easy, right? You could try problems like that. Okay, let's flip it over. Let's find something just slightly more difficult. DeMoivre's theorem. So DeMoivre's theorem, extremely useful in getting to where we need to get, and it really says this. If z is equal to r cosine of theta plus I sine of theta, then I'm going to take z and I'm going to take it to the nth power. So if you raise z to the nth power, you're going to multiply z times z times z times z. You're going to multiply that n times, right? So how many times did you multiply the r's? Yeah, so you would have r to the n. How many times did you add up the thetas? Yeah, so, okay, so you're kind of looking here, right? You're kind of wondering, okay, what is it that we're doing? So here's what we're doing. If we go back to this spot right here that we were talking about, remember the multiplication. So I'm going to look at this part right here, okay, to connect your learning. Well, so what it's saying, Kaylee, is I have a z1, and I'm going to multiply it by a z1. I'm just going to multiply it by itself. I'm going to say square it. Well, then you would have r1 times r1, or r sub 1 squared. And you would have theta sub 1 plus theta sub 1, or theta sub 1 times 2. So all we're going to do is we're just going to multiply the same number many times. And what that's going to result in is we're going to take that r, it'll just be the nth power because we multiply it n times. And we're going to multiply that by cosine of, and we're going theta plus theta plus theta plus theta plus theta n times. So the cosine of n times theta. Watch the formula, and you'll see it work. It's absolutely beautiful. Beautiful. Are you ready? This is the cool part. This is, okay, I'm starting to wake up. I'm excited. 1/2 plus 1/2 I to the 10th power. Do you really want to do that? Oh my gosh, 1/2 plus 1/2 I to, we got to multiply that about 10 times. We haven't even learned the binomial theorem yet. Forget about a shortcut to this thing. That's nasty. I don't want to do that. Let's use DeMoivre's theorem. DeMoivre's theorem requires that it be in what form? Trigonometric form. So first, let's put it in trigonometric form. We're going to convert this to r cosine of theta plus I sine of theta. If we do that, then we can apply DeMoivre's theorem. Remember how we find r. Square root of a squared plus b squared. So r is equal to the square root of, what's 1/2 squared? 1/4. What's a fourth plus a fourth? 1/8. No, half. So you get the square root of a half. It's okay. The higher math you do, the stupider you get anyway. So it's just kind of the way it goes. You can take the square root of 1, right? And you get 1 over the square root of 2. Rationalize the denominator. Square root of 2 over 2, right? Does that look familiar? Sure does. Okay, so we got the square root of 2 over 2. That's my r value. So now, is everybody clear how to find r? And that's called our modulus. Now what I need to do is I need to find my theta value. And theta has to satisfy tangent of theta is equal to b over a. What's b over a? 1/2 over 1/2 is 1. We got a half over half is 1. This complex number is it in the first, second, third, or fourth quadrant? First quadrant. So what angle is tangent of theta equal to 1 in the first quadrant? Pi over 4. Everybody got it? So we've got theta is equal to pi over 4. Yes. So if we had 1 minus 1/2, 1/2 minus 1/2 I, that would be in the fourth quadrant, right? Because over 1/2 and down 1/2, like from what we plotted yesterday. Does that make sense? If they're both negative, then it would be in the third quadrant, okay? All right, so let's carry this out. We have the trigonometric form is the square root of 2 over 2, right? Times the cosine of pi over 4 plus I sine of pi over 4. Now we want to take that to what power? Yeah, we want to take this thing to the 10th power. Well, what DeMoivre's theorem says is this really isn't that bad at all. We just have to take the radius and raise it to the 10th power. So I'm going to write square root of 2 over 2 to the 10th. Times the cosine of, and then what do I do with the angles? Multiply them by 10. So I have 10 times pi over 4 plus I sine of 10 times pi over 4. We're not quite done. We're really close. Okay, we're really close. Okay. Very close. Square root of 2 over 2. That's like 2 to the 1/2, right? Over 2 to the 1 to the 10th power. What do I do with my exponents? Multiply them. So I get 2 to the 5th over 2 to the 10th. 2 to the 5th over 2 to the 10th is 1 over 2 to the 5th. There you go. Times the cosine of 10 pi over 4. What's that? 5 pi over 2. Plus I sine of 5 pi over 2. That works. And I'll give you credit for that on the test. I just want to show you one last thing that kind of makes this go around, okay? This is something you should understand. 5 pi over 2. 90 degrees is pi over 2, right? So watch. 1 pi over 2. 2 pi over 2. Well, they can't see that on YouTube, can they? Okay. 1 pi over 2. 2 pi over 2. 3 pi over 2. 4 pi over 2. 5 pi over 2. So 5 pi over 2 is the same as what? It's pi over 2. It's in the same spot, right? So the cosine of 5 pi over 2 would be the exact same as sine of pi over 2, or as cosine of pi over 2. That's the way your book's going to write it. Hey guys, I'll give you credit for that on the test. But really, you should reduce it one more step and go 1 over 2 to the 5th times the cosine of pi over 2 plus I sine of pi over 2. We should really try to write our angles between 0 and 360, or 0 and 2 pi. I think we need to leave it there. I think you guys need to try an example on your own. Are you ready? Here's your example. Blank sheet of paper, back your notes, whatever you want. I don't care. Here's your problem. -1 plus I squared to 3 8th power. Okay? 8th power. See if you can do that without actually... You guys, again, appreciate. Could you imagine how long we would sit here if we multiplied this out 8 times? And once you say 8 times, forget about 8. Think about 800. Yeah. Okay? It doesn't really matter what power you'd raise it to. It'd end up being about the same amount of time. Just try to work through this and see about where you're at. Okay? So give that one a shot. We'll work on that. But you guys need to practice this. Okay, so let's pretend like YouTube Nation. We'll just see where they're at. They have no idea what's going on. We'll do a perfect job of explaining this problem. Remember that trigonometric form is r cosine of theta plus I sine of theta. And so some of you guys had the question again, how do you find r? R is equal to, we said it's the modulus, which is the absolute value or the distance it is away from the origin. And you guys figured that out by taking square root of a squared plus b squared. It's just the Pythagorean theorem, where this value is a and this value is b. Because remember yesterday we plotted that point, right? We plotted that. We said back 1 and then up the square root of 3. So that's approximately what we have. And so what we're doing is we're trying to come up with an r value and a theta value. Well, the r value is going to be this length right here. The theta value is going to be the rotation to get us there, and that's going to tell us about that point plot. So if you work this out, we have r is equal to the square root of -1 squared plus the square root of 3 squared. And you guys came up with a value of 2. And so 2 is the correct r value. Then you have to figure out theta. And which quadrant are we working in? You can see from the graph that we drew that you're in the second quadrant. So you have to satisfy tangent of theta is going to be equal to b, which is the positive square root of 3 divided by -1. So tangent of theta is going to have to be equal to negative square root of 3. We solved in radians in the second quadrant, 2 pi over 3. So theta is 2 pi over 3. So those two values, 2 and 2 pi over 3, that's from yesterday. That's going to be kind of, basics on the test. Got to be able to come up with that. So when I gave the test, when I asked people, I said, hey, find this. This would be a great test question. That's one that I would give. If you can't find the r value right away and the theta value, well, then the rest really doesn't matter, does it? Because then you can't apply DeMoivre's theorem. And DeMoivre's theorem says is we're going to take that. We're going to take 2 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. And we're going to raise that all to the 8th power. And what DeMoivre's theorem says is that you can take 2 and raise it to the 8th. Now, whether you write 2 to the 8th or 256, I don't care. Because again, if it was 2 to the 800, we wouldn't actually write that out, right? So, but then we have cosine of, we multiply those by 8. And so you just have 16 pi over 3 plus I sine of 16 pi over 3. So that was pretty quick. We're done. That's what it is. Now, I would reduce it one step further, and here's how I do it. So I don't like 16 pi over 3 because I can't conceptualize what 16 pi over 3 is, because to me that's a lot of rotations. So here's what I write. I say this is 3 pi over 3, so I look at my denominator, so I make that 1 pi, or 3 pi over 3. I make this 6 pi over 3. So then, I kind of thinking this in my head. This would be pi over 3. This would be 2 pi over 3. This would be, 4 pi over 3. This would be 5 pi over 3. Something like that, right? And I just start to go around the circle. So 6 pi over 3. 12 pi over 3, right? 15 pi over 3. 16 pi over 3. So that brings me to 4 pi over 3. So the real answer is 2 to the 8th cosine of 4 pi over 3 plus I sine of 4 pi over 3. And that's that. Now, one last thing I want to state here, though, is there's, you don't necessarily have to draw that. I feel like that's helpful for people to see that. Really, you're just taking 16 pi over 3 and you're subtracting off 360 degrees each time, right? So if you subtract off 360 or 2 pi or 6 pi over 3, you get 10 pi over 3, right? Well, is that between 0 and 360? No, so we subtract off 6 pi over 3 again, and you get 4 pi over 3. So that's what we're doing mathematically. Those are called coterminal angles that we did back in 5.2 lesson. So okay, time to practice. You guys did well today. Okay, so we're going to do section 7.6, page number 590. And I think it would be really good if we tried, so the easy problems that we started off with would be 47 through 49. You just do the basic, multiplication and division piece. 55, you'll do the same thing, multiplication, division, but you have to transform it into trigonometric form first. So that'll be good practice for us. So This is DeMoivre's theorem right here, those three. So you practice three like that. And after you practice one in class, I think it will go quicker. Remember, put it in trigonometric form, then apply DeMoivre's theorem. This one's the basic multiplication and division that we started out with. And then this one right here, you have to put it in trig form first. Then multiplication and division. So see how they tie together, you know. So that's what I'm trying to do for you. So not a lot of problems, 7, but you know the DeMoivre's problems could be challenging if you really don't know what you're doing. And it starts out really cool. You're doing 1 plus I to the 20th power. I mean, again, just think about actually doing that. That's absurd, right? It's absurd. But you guys can do it, and you can do it rather quickly. And I'm sure you'll do just great. Good luck. You've got some time to work on that. Bye, everybody who's not here. Good luck.